Hi, I'm John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. On this video, we're going to talk about how to use the discriminant of a quadratic equation to determine the nature of its roots. Let's start. The general form for any quadratic equation is given by this form: ax squared plus bx plus c is equal to 0. A is the coefficient of x squared, b is the coefficient of x, and c is the constant term. The condition also to keep in mind is that a is not equal to 0, otherwise this will just be any other linear equation. We've seen in an earlier video that this is the quadratic formula, how to use the quadratic formula to find the roots of a quadratic equation. The roots are also known as the x-intercept, the solutions, the zero, these are all synonyms. And we've seen this in a different video. I'm going to link that video in the description box below if you haven't already seen that. In this video, what we're going to do is that we're going to unpack this formula, the quadratic formula, right? So this can be actually written in two groups, negative b over 2a, and the second part can be written as under root of b squared minus 4ac over 2a. Okay, so there are two parts. Literally, there are two parts. The first part is this negative b over 2a. And the second part is this plus or minus under root of b squared minus 4ac over 2a. This first part, can you guys see this? All right, here we go. This first part gives us the x-coordinate of the vertex. Okay, in an earlier video, we've discussed the quadratic curve. When we were talking about the quadratic curve and the vertex, we already noted this before, that the x-coordinate of the vertex is given by negative b over 2a. And that is what I meant when I said in that earlier video that the quadratic formula, there's a lot of information packed into it. And one of the information is that it also contains the x-coordinate of the vertex of the parabola. The second term is under root of b squared minus 4ac over 2a. Here, the term that's of most important to us is this term under the radical, under the square root sign, b squared minus 4ac. This term is very, very important. This is called the discriminant. The discriminant. The discriminant, it's called the discriminant because it sort of discriminates or tells us, differentiates the idea of the roots, which we say, which we call the nature of the roots. Nature of the roots. Okay, so this discriminant actually helps us differentiate or discriminate the nature of the roots, helps us identify, even without graphing, what the nature of the roots are going to be. So if you're given the quadratic equation in its standard form, in its general form, ax squared plus bx plus c, just by identifying a, b, and c correctly and using the discriminant, you'll be able to differentiate or discriminate the idea of the nature of the roots of that given quadratic equation. Let's see what it means. Okay, so whenever this term b squared minus 4ac is negative, whenever you evaluate and you find that it is a negative number, not interested in the number, what that number value is, but if it's negative, we say that there are no real roots, okay? It may be a complex root, an imaginary root, but we'll discuss that in some other video. But for now, we're just going to say that b squared minus 4ac is negative, means that there's no real roots. Graphically, it means that the curve, the parabola, does not touch the x-axis. So if that's the x-axis, the parabola just goes away without touching the x-axis. It turns away. This could be the case when a is positive, but if a is negative, you're going to have the same case. If that's the x-axis, then the quadratic basically does not even come close to the x-axis. It just moves away. That's your vertex. Okay, so that's when a is negative, and when b squared minus 4ac, the discriminant is negative. Cool. Then when we look at the case when the discriminant b squared minus 4ac is equal to 0, our conclusion is that there's only one real root. One real root means that it's going to touch the x-axis just once. It's just touching or kissing the x-axis, okay? What it looks like on the graph is something like this. That's our vertex, okay? And this is the case when a is positive. And likewise, when you have a case when the a is negative, it's an inverted graph, and that's our vertex. This is the case when a is negative. So for both of these, we have seen that b squared minus 4ac is going to be equal to 0. All right, so b squared minus 4ac equal to 0 means there's one real root. Just one real root means that it touches the x-axis in exactly 1 point. Okay, the other thing is when b squared minus 4ac is greater than 0. That's the third scenario. Okay, b square minus 4ac is greater than 0 means that you're going to have two real roots. Two real roots means that it's going to touch the x-axis twice. This is also something that is described as two distinct or unique solutions. Okay, touches the x-axis two times. So that's the graph, and we say this is the case. Of course, these are the two different roots, and this is the case when a is negative. It's an inverted parabola. And in the same way, if you have our coordinate system that way, and if this is our quadratic, this is the case where, let me use another color, this is our x intercepts. This is the case where a is positive, and we said b square minus 4ac is greater than 0. Now let's just illustrate this with some examples, how we can use the discriminant to determine the nature of the roots of some equations. Okay, so our first example is going to be, I'm just going to write this thing down as example 1. What's the equation? It's 3x squared plus a 10x plus 9 is equal to a 0. Can you guys see this? All right, there you go. You can see this now. The first thing to do when you are trying to identify the nature of the roots, okay, this is nature of the roots means we're using the discriminant. So first thing to do is identify what's a. A is 3, b is 10, and c is 9. Can you see this? All right. So the first thing we do is that we find out what is b square minus 4ac. b square minus 4ac is then going to be equal to 10 square minus 4 times 3 times a 9. So when we evaluate this further, we'll get 100 minus 4 and 3 is 12. 12 and 9, 12 times 9 must be 108. And that's a negative 8, giving us the fact that this discriminant b square minus 4ac is negative. And our conclusion, if it's negative, is that this quadratic equation that we started off with, this quadratic equation, therefore, the quadratic equation has no real roots. Okay, that will be our conclusion. We just say that it has no real roots. We're not interested in complex or imaginary roots in this particular video. We'll talk about that when we do another video, another study on complex numbers. But as for now, you just find out a, b, and c, and you look for the discriminant. The discriminant b square minus 4ac is negative. That means that the quadratic equation has no real roots. Let's confirm this idea on our graphing utility, because we said that no real roots means that the quadratic equation must not touch the x-axis, right? So if we go to our graphing utility, and I'm just going to enter the quadratic as y is equal to, okay, because f of x stands for the y value. So this, the quadratic equation basically is the y value, 3x squared plus 10x plus 9. So I'm just going to enter it as 3x squared. This is the y value. For those of you who haven't seen the earlier video that I've made on the parabola, the graph of the parabola, maybe you want to go and check it out, why we are entering 3x squared plus 10x plus 9 as the y value. So when I hit enter, I can see the parabola, the quadratic, the graph of that parabola, and I can see clearly that it does not touch the x-axis. And it's the same thing that we saw using the algebraic method, that when the discriminant is negative, the quadratic has no real roots, which was confirmed to us even using the graphing calculator. So even without the graphing utility, if you're not even allowed to use the calculator, you can use the algebra of the discriminant to determine the nature. And the nature of the root is that it has no real root. That's what we mean by the nature. So whether it's real, real and repeated, or whether it's going to be imaginary. So we have confirmed with the graphing calculator. Let's take another example, okay, for this discriminant. So we are going to take an example 2, which is going to be 6x squared plus 12x minus 24 is equal to 0. That's our second example for a quadratic. First thing, as we always do, identify your a, your b, and your c. All right. So now when we are looking for the discriminant, which is b squared minus 4ac, we can write it down as 12 squared minus 4 times 6 times a negative 24. Remember, we are not looking for the value, but just for the sign of this discriminant, the sign, okay, whether it's positive, negative, or 0. So on further simplification, we'll get this as 144 minus, and minus is plus. This is 24 times 24. 24 times 24, the square of 24 is 576. Is that right? Let me just check. 24, 24, 4, 4, 16, 4, 2, 8, plus 1, 9. That is 2, 4, 8, 2, 2, 4, and 6 and 7 and 576 is correct. So here we go. But even then, we're not interested in the value. We can see clearly that this is positive. Okay, the discriminant is positive. 144 plus 576 happens to be a positive number, which means that this discriminant is positive. And our analysis said that when the discriminant is positive, our conclusion is that this the quadratic equation has two distinct real roots. Okay, two distinct real roots only based on the algebra that b square minus 4ac is positive. Now, when b square minus 4ac is positive, you can also have two different conditions. Okay, the two conditions are when that b square minus 4ac is a perfect square, because it can be a square number or it may not be a square number. For in this case, you have 576 plus 144. What do we have? This is 10 and 11 and 112. And that's 6 and 1, 7. 720 is not a square number, all right? It's not a square number. So whenever this discriminant is a perfect square, you can say that the quadratic equation can be factored. We ended the last video by saying that not all quadratic equations can be factored. And this is another information that the discriminant gives us. So it's really powerful, as you can see. Not only just telling us the nature of the roots, but also if b square minus 4ac is a perfect square, then and only then will the quadratic equation be factored. The other thing is that if it's a perfect square, then the roots will be rational roots. So it's a case of a real roots. That means two distinct real roots, but those roots will be rational, all right? In this case, because it's not a perfect square, because it's 720, which is not a perfect square, you'll have irrational roots. So two distinct irrational roots, that's okay. The quadratic cuts the x-axis in two different points, and we don't want to confirm that, do we? Let's just go and confirm it anyway, because we have a graphing utility here. And I want to also encourage those of you who perhaps do not use a graphing utility for your course. Maybe you're not required to use a graphing utility. I would say that there are several graphing software available online that's free, something like Desmos. You could use that just to deepen your understanding. What you see algebraically, that b square minus 4ac is negative and it does not cut the x-axis, or b square minus 4ac is positive. Just seeing that really helps. Okay, so what we'll do is that I've already entered this second question. I'm just going to go and activate that. And you can see that the red graph is our second question. And we can't see the entire graph because the turning point is way, way, way below there. If you want to see that, you can. But anyway, you can see the intercepts. We're more interested in the x-intercepts, that's cutting the x-axis in two different points. And this other graph, this was the first question, it's not even touching the x-axis, okay? But if you want to see the turning point also, you can go here and fix a zoom. And if I say zoom fit, that will fit, and you can see that the red graph, now you can see clearly that it's cutting the x-axis in two different points. However, there's another issue here, that the blue graph, it looks like that the blue graph is touching the x-axis. Can you see that? And that's because of the scale factor. This particular graphing utility probably does not have a very good aspect ratio, and therefore in comparison with the red graph, it looks like it's touching, but actually it's not touching. I'll just go ahead and turn off the red graph, and then I'll make it a standard zoom. Windows zoom, and let's call it zoom standard. And here you can see that in its original standard position of the scale, that the first question that we saw where the discriminant was negative, it has no real roots, meaning that graph was not touching the x-axis, whereas this red graph was this particular question where we saw that the discriminant was positive and the graph had two distinct real roots. Okay, so let's quickly recap what we saw today. The discriminant of a quadratic equation is actually that one term. There are two important terms part of that quadratic formula. This one term under that radical is called b square minus 4ac, which we call the discriminant. It's called the discriminant because it discriminates or helps us differentiate the nature of the roots, okay? Whether it's real and distinct, whether it's real or repeated, or whether it is a complex or an imaginary root. And based on the sign of the discriminant, not so much of the value. When b square minus 4ac is negative, we say there are no real roots. That means that the graph does not touch the x-axis. When b square minus 4ac is equal to 0, we say there's just one real root. The graph literally just touches or kisses the x-axis in one point only. And when b square minus 4ac is greater than 0, we said that the graph or the quadratic has two real roots. It cuts the x-axis in two distinct points. But we also made another observation that when b square minus 4ac is a perfect square, a square number, that's only when we say that the quadratic can be factored, okay? That's the only case when the quadratic equation can be factored. and not otherwise. Now let's try a very different kind of a question. This will be our example 3. For what values of k will the quadratic what's my equation out here? It's kx square plus 4x plus a k minus 3 equal to 0 have equal roots. Okay, so I'm going to read this question out to you again. For what values of k will the quadratic kx squared plus 4x plus a k minus 3 is equal to 0 will have equal roots? This is a k minus 3, okay? I put it into a bracket. K minus 3 have equal roots, okay? So again, we are going to use this idea of the discriminant. It's a different kind of a question where you have to find the values of k which will guarantee that that quadratic equation will have 2 equal roots. So it's another application of the discriminant. So what do? We first identify a, b, and c, just like we did before. So for this quadratic, a is k, b is 4, and c is that k minus 3. So now when we find the discriminant, that's b square minus 4ac, that would be 4 square minus 4 times k times a k minus 3. Okay, that's the discriminant. That's the expression for the discriminant. And we know that this is going to be 16 minus 4k times a k minus 3. And this works out to 16 minus 4k square plus 4 and 3 is a 12k. This is the discriminant, okay? And it's surprising that this discriminant is now another quadratic. So it's almost like a quadratic within a quadratic, okay? This is another quadratic within a quadratic, but the second quadratic in k is actually the discriminant of the original quadratic. And what are we trying to do? We're trying to find out when will that original quadratic have equal roots. And the quadratic has equal roots. The quadratic will have equal roots when this expression that we found out, this one is equal to 0, okay? When 16 minus 4k square plus a 12k is going to be equal to 0, okay? So that would mean when I multiply by -1 throughout, I'd get 4k square minus 12k minus 16 equals 0. I can factor out 4, and that would give me k square minus 3k and minus 4. And I believe this can be factored as k minus 4k plus 1 is equal to 0. Let me just check my factoring. Minus 4k plus 1k minus 3. Yeah, that should be correct. And that means the values of k, this means that k should be 4 or k is equal to -1. So for these values of k, when k is equal to 4 or when k is equal to -1, our discriminant is going to be equal to 0, which means that for those values of k, this quadratic kx squared plus 4x plus k minus 1 is equal to 0 will have equal roots. All right, so I hope that this video was useful to you to understand the power of the discriminant. It's still part of that quadratic formula that looks so innocent, but it's loaded with information. I'm going to see you all in the next video.